I'm Judy Sandrock, and in this video, I'm covering space agriculture, growing food in outer space. It's also going to include links to Jacob Pepperseed Torres from NASA. This is part of the CTE Momentum, Your Place in Space Challenge. Why is space agriculture so important to us? It's important so that we can sustain long-term space missions, reduce dependency on Earth-based supplies, and open new career paths in agriculture, biology, and engineering. This graphic shows us an artistic representation of a habitat on the surface of Mars, where food is being grown in a very controlled environment. And what are the challenges and solutions that come with trying to grow food in space? There are some unique challenges for space agriculture. First of all, microgravity, or lower gravity than our home planet Earth. Lack of natural sunlight. There's limitations in space in terms of just the size of habitats, and that we can't go outdoors and open the windows and open the doors, and the harsh environmental conditions. In this graphic, we can see some chili plants that are being grown on the International Space Station. The challenges with microgravity or zero gravity conditions is that the roots, because they have no gravity, they don't know which direction to grow in. And also there's a number of challenges where we actually rely on gravity a lot in terms of irrigating plants. We're expecting the water to sink into the soil due to gravity, and this doesn't happen. So we have to look at novel solutions when we're dealing with microgravity or zero gravity conditions. Innovative solutions that have been developed include hydroponics and aeroponics. So hydroponics is where we actually add the nutrients to the water and then spray that onto the plants, or otherwise inject it into the soil. Artificial light sources, there are a number of experiments, and Jacob Torres covers that in his video that we link to in the description of this video. It's a much longer workshop, roughly an hour long. But here he actually covers the role of artificial light sources, because plants don't need the entire spectrum that we could give them. So if we just focus on applying literally our energy that's available to certain frequencies and wavelengths, then we can certainly assist in plant growth. And we also need to look at modular and scalable designs, so that what we can do is we can travel to Mars with what we need for the space trip, and then once we're there, we can actually scale it. So back to Jacob Pepperseed Torres. Jacob feels blessed to be part of the NASA space biology team at Kennedy Space Center, where they're growing crops on the International Space Station in controlled environments to ultimately feed the crew. And also there's a number of resources. So I'm just showing it here on the slide, but you can find these links in the description.